In just a few moments' time, when we dive underwater, this submarine will become essentially invisible, undetectable to anyone.
The Virginia class is acoustically the stealthiest submarine that the U.S. Navy has ever produced.
Beneath the quiet surface of the ocean, America is preparing something that doesn't just hide, it nearly vanishes. The title says it's invisible, but the real reason behind that invisibility is far more surprising than most expect. This new underwater weapon doesn't rely on size or speed alone. There's a single design choice deep inside the vessel that changes everything. And once you hear it, the whole idea of stealth will make more sense. What this choice leads to is something few are ready for. And it's only the beginning. The stealth advantage. Underneath the crushing pressure of the deep Atlantic, a submarine like the USS Virginia becomes nearly undetectable, mastering the art of invisibility beneath the waves. The Virginia class is considered the stealthiest submarine the U.S. Navy has ever produced. A true giant cloaked in silence. Its massive steel hull, over 370 feet long and weighing close to 8 million kilograms submerged, is engineered not just for strength, but for secrecy. When it moves, it emits so little sound that even the most advanced enemy sensors struggle to pick up its presence. Sound is the lifeblood of submarine warfare. Since light barely penetrates the depths, sonar is the primary way these vessels detect others and avoid detection themselves. The Virginia class uses a combination of advanced hull design, noise-dampening technology, and special propulsion systems to reduce vibrations and sounds to near invisibility. This acoustic stealth turns the submarine into a ghost, gliding, hunting, and striking without warning. To survive and dominate beneath the sea, being undetectable isn't just an advantage, it's essential. Stealth is more than just hiding sound. It's about thwarting complex detection methods that adversaries constantly improve. Submarines must remain evasive even as underwater sensors grow more sensitive, and the Virginia class achieves this through painstaking design and constant upgrades. Its hull is shaped and coated to minimize sonar reflections, while internal components are mounted on vibration-isolating fittings to prevent noise leaks. Every bolt, panel, and pump is scrutinized for noise, ensuring the submarine operates as quietly as the ocean itself. One compelling example of these precautions is how the submarine pushes water. Traditional propellers create bubbles and noise that can betray a sub's location miles away. The Virginia employs a pump jet propulsion system, a ducted fan that moves water smoothly without cavitation, greatly reducing bubbling and vibration. This innovation cuts down the telltale signatures that so often reveal a submarine's position, especially crucial when it needs to sneak through contested waters or evade faster threats. This stealth doesn't just protect the submarine. It changes how naval engagements unfold. A truly hidden vessel can get close to enemy fleets, gather intelligence, or strike with missiles and torpedoes without ever being detected. The Virginia class packs an arsenal, yet it counts on silence as its first and best weapon. Such superiority forces potential adversaries to rethink their anti-submarine tactics, raising the stakes in underwater warfare. But acoustic stealth does not come easily nor cheaply. The Virginia program had to balance cutting-edge noise reduction technologies with realistic costs and production timelines. Earlier submarines like the Seawolf were powerful but extremely expensive, with price tags upwards of $3 billion per boat, an unsustainable model after the Cold War. The Navy sought to maintain deadly stealth capabilities while making the submarines more affordable and versatile for 21st century missions. The resulting Virginia-class was designed to be stealthy in both deep ocean and shallow coastal zones, an environment where noise and turbulence challenge detection efforts. This multi-role stealth capability means it can hunt enemy subs far offshore or slip quietly into congested littoral waters, making it a formidable tool for modern naval strategy. This advantage continues to evolve as newer boats in the class upgrade sensors and quieting technology. While the submarine's stealth is impressive, it's only part of what makes it so revolutionary. The next layers of innovation lie beneath the surface of its construction and onboard technology, where smart design and digital invention reshape how submarines are built and operated. Understanding these breakthroughs offers insight into how the U.S. keeps its underwater edge decades into the future. Engineering the invisible is only the beginning. How the Virginia-class is built and controlled is equally key to its success and the future of silent undersea warfare. Revolutionary construction techniques. The Virginia-class submarines owe much of their success to groundbreaking approaches in how they are built. Instead of traditional continuous construction in a single shipyard, the Navy split work between two historic builders, Electric Boat in Groton, Connecticut, and Newport News Shipbuilding in Virginia. Each yard assembles major pre-outfitted hull sections, which are then joined together, boosting efficiency, reducing bottlenecks, and maintaining a steady production rhythm. This collaboration allows the Navy to keep a predictable schedule and preserve skilled workforces in separate locations. This modular construction revolutionizes submarine building by shifting from cramped, difficult workspaces inside welded hulls to open floors where teams install miles of piping, thousands of cables, and critical systems before the sections are welded together. Workers fit pumps, tanks, and electronic systems into these large, cylindrical pressure hull rings while they're still open and accessible. The result is better quality control, faster work, and fewer errors that would be costly and time-consuming to fix later. The core of this process is the ability to build the Virginia-class submarines entirely in digital 3 dimensions. Unlike older designs relying on paper blueprints, engineers create a living digital twin, a complete computer model that integrates every pipe, valve, and cable. This 3D model allows designers to spot conflicts or spatial clashes between systems early, preventing construction problems and redesigns. It also transforms the upgrade process, enabling virtual changes that improve capabilities without costly physical overhauls. With this digital foundation, customizing submarines or integrating new technology becomes far simpler. Want to add a new electronic gear or relocate a bulkhead? The design team tests it virtually, verifies airflow, cable runs, and shock mounts, then rolls it into production with confidence. This forward-looking approach ensures the Virginia-class remains adaptable, evolving with technological advances without rebuilding entire sections. The modular method also highlights the advantages of cost control, and as such, these submarines become cheaper than their predecessors. The Seawolf class, which was designed to meet Cold War requirements, cost about $3 billion each, and this steep price limited the number of boats built to a few. The Virginia program aimed at furnishing very similar capabilities at a fraction of that cost, which indirectly paved the way for the Navy to build more units while also extending the mission profiles. The efficient construction practice is pivotal to the maintenance of the fleet's size and readiness over the long period of 30 years. This building method backs up a fast production line in which the work of one boat is conducted immediately after the last one, and both skilled laborers are kept busy and the delays are minimized. The constant output satisfies the strategic demand without compromising on quality or technological advancement. It is a pattern that combines the industrial productivity with the intricacy of the nuclear submarine manufacturing, a capability that only a few nations can possess. Cranes that are taller than buildings are used in these yards to manipulate huge rings of steel and weld them together like pieces of a puzzle to make a full-length pressure hull. This colossal production combines raw steel, highly skilled engineers, and artisans. The modular design also facilitates easy maintenance and mid-life upgrades, which are the main characteristics of operational life extension of each unit. In the meantime, the inside innovations were the ones that not only redesigned the vessel, but also the crew's perception and command of the ship. The change from conventional optics to digital vision systems not only changes the equipment, but also the submarine crew's experience in the control room. This is another significant step forward in the development process. The marriage of smart design and smart construction sets the stage for a new era of underwater stealth and power. Digital periscopes and control rooms. One of the boldest changes in the Virginia class was the abandonment of the traditional optical periscope, a technology unchanged for over a century. Instead, the submarines deploy photonic masts, slim, camera-equipped towers that rise through the sail without breaching the pressure hull. Unlike the classic periscope, which required a direct optical path and constrained the command center's location, these digital masts send high-definition images down fiber optic cables, freeing up internal space. Inside the control room, this is a game-changer. The crew no longer peers through a narrow, magnified tube, but instead maneuvers using panoramic digital displays projected on wide screens. This richer, clearer view of the surface and horizon not only enhances situational awareness, but also reduces eye strain and fatigue during long watches. Commanders can zoom, pan, and record imagery, sharing information immediately and coordinating more effectively. For submarine builders, ditching the periscope shaft allowed much greater flexibility in layout. The control room could move away from directly under the sail to a wider, lower location inside the hull, making it safer and more spacious. This relocation supports a more ergonomic environment, improving crew comfort on deployments that often last months. It also means better protection from attack and underwater pressure. The traditional hand controls were replaced with something surprisingly simple: a game controller. Originally, operators used a helicopter-style joystick that many found unwieldy, but testing revealed that a common video game controller offered greater precision, was easier to learn, and more intuitive for younger sailors. This inexpensive switch boosted efficiency and eased the training curve for new crew members. These digital upgrades are part of a broader trend to modernize submarine operations. The Virginia-class's control systems integrate with advanced sonar and combat systems, feeding the command team real-time, high-resolution data. Digital displays streamline navigation, targeting, and communication, making the submarine a smarter weapon system. The seamless interface helps sailors manage complexity while maintaining stealth. This evolution in command technology is also vital for integration with unmanned systems. The digital infrastructure aboard the Virginia prepares the submarine to coordinate with remotely operated drones and sensors, extending its reach while reducing risk. Such capabilities will multiply mission options and redefine underwater tactics. By breaking free from century-old design constraints, the Virginia-class has created a control center that matches the sophistication of its stealth and firepower. The submarine becomes not just a vessel, but a high-tech combat node, blending human skill with digital precision beneath the sea. This leap forward in control systems paves the way for even more transformative innovations that will shape the next generation of undersea warfare. Power, propulsion, and silence. At the heart of the Virginia-class submarine beats a nuclear reactor known as the S9G core, designed to last the vessel's entire service life. This reactor produces steam that powers turbines, which in turn drive the propulsion system. Unlike traditional submarines that rely on bare propellers, the Virginia-class uses a pump jet, essentially a ringed fan hidden inside a duct that pushes water with smoother, quieter flow. This design greatly reduces cavitation, the formation of noisy bubbles that can betray a submarine's position to enemy sensors. The submarine officially dives deeper than 800 feet and operates at speeds exceeding 25 knots, around 29 miles per hour, although exact capabilities remain classified for security reasons. Speed allows the Virginia to quickly maneuver, chase threats, or escape danger. But achieving this velocity without compromising stealth is a challenge. Pushing a massive steel vessel through water at high speeds usually creates a significant acoustic signature. Yet through careful engineering, the Virginia balances speed and silence, avoiding the unfortunate trade-off that faster submarines tend to be louder. The pump jet propulsion also means the submarine can operate in shallow coastal zones, where traditional props would generate unmistakable noise and bubbles. This versatility ensures that the Virginia can slip through contested littoral waters, opening mission possibilities beyond deep-sea patrols. The quieter propulsion extends not only its offensive potential, but also its intelligence gathering and surveillance roles. Being able to remain unseen and unheard in diverse environments gives the U.S. Navy a significant strategic advantage. Beyond propulsion, every component aboard the submarine is engineered with noise reduction in mind. Pumps are mounted on vibration isolators, cables and panels are secured tightly to prevent rattling, and machinery rooms are acoustically shielded. Crew routines even prioritize minimizing sound, with sailors trained to move and operate quietly throughout the vessel. This meticulous attention to detail ensures the submarine's acoustic signature remains one of the smallest in the world, making it almost impossible to detect in noisy ocean environments. The durability of the reactor is a factor that determines the endurance of operations. The nuclear fuel, which is never replaced throughout the whole life of the submarine, enables the Virginia to stay submerged and deployed for months longer than other submarines. Such a long-lasting endurance is vital for stealth missions, which depend on surprise and secrecy. Unlike the diesel submarines that have to come up to the surface often, nuclear submarines like the Virginia keep their underwater presence continuous and silently control large ocean areas. Nuclear power has also liberated the submarine from the dependence on oxygen systems, thus making it capable of diving deeper and staying longer underwater. The underwater capability of the submarine keeps it safe from surface threats, and also grants it more tactical flexibility. The quiet propulsion combined with Virginia's stealthiness makes it a near-invisible hunter that can either shadow the enemies or carry out espionage operations with very little risk of getting detected. Although power and propulsion are considered just mechanical issues, in this case, they are the main elements of a stealth strategy that goes far beyond simply being fast or deep. They play a vital role in the submarine's operations of intelligence gathering, weapon deployment, and countermeasures evasion. The engineering victory is to make such a huge and complicated ship acoustically disappear under the ocean's natural background noise. Power and propulsion, no matter how impressive, only constitute part of the submarine's ears and brain. The sensor and combat systems of the Virginia-class complete the picture, allowing for the transformation of raw data into actionable insights while the sub's location remains undisclosed. Beneath the surface murmur of the ocean, Virginia's advanced sensors listen intensely, converting noise into knowledge that protects the submarine while hunting enemies. Advanced sensors and combat systems. The Virginia-class is equipped with a sophisticated suite of sonar and sensing arrays that make it a master of underwater perception. At the bow, early models featured a large spherical sonar array, replaced in later iterations by a horseshoe-shaped water-backed array. This wide-aperture bow array offers cleaner acoustic coverage over the frequencies that matter most for detection and identification. Combat effectiveness depends on such clarity. Hearing the faintest hint of a rival submarine or surface vessel can mean the difference between survival and silence. Flanking the hull are extensive wide-aperture arrays, functioning like giant underwater ears that provide a tall and broad acoustic picture of the surrounding ocean noise. These sensors work together to detect and characterize distant contacts in cluttered or open waters alike. High-frequency chin arrays placed below the bow provide close-in protection, sensing mines, torpedoes, or underwater obstacles. Additional panels mounted on the sail assist in navigating tricky environments such as under ice or near coastal clutter. All of this raw acoustic data feeds into the Navy's combat system, called the AN/BYG-1. This open architecture platform allows continuous insertion of new processing power and software updates without overhauling bulky hardware. Thanks to this design, the submarine can incorporate the latest advances in data analysis, machine learning, and artificial intelligence. The system's adaptability means that the sub's brain grows smarter over time, improving threat detection, classification, and engagement capabilities without lengthy yard periods. This continuous upgrade capability is crucial given the rapid technological advances in undersea warfare. Potential adversaries develop new countermeasures and stealth tactics that require an equally agile response. The combat system harmonizes sensor data, presents it clearly to the crew, and automates some of the decision-making processes, easing operator workload in intense situations. When it's time to attack, the Virginia utilizes the Mark 48 Advanced Capability Torpedo, an advanced heavyweight weapon updated through software upgrades to improve sonar and targeting without needing a hardware swap. This modular approach extends weapon service life while enhancing performance in shallow water and challenging acoustic conditions. The wire-guided torpedo allows the fire control team to direct the initial phase of the attack before the weapon switches to autonomous target tracking. Offensively, Virginia also carries land attack cruise missiles, with early boats housing a dozen small vertical launch tubes for Tomahawk missiles. Later versions replaced these with 2 large payload tubes, each housing 6 Tomahawks, with ranges around 1,000 miles. The most dramatic increase in strike power came with the Virginia Payload Module, an inserted mid-body section adding 4 tubes that can each carry 7 Tomahawks, 7 substantially boosting firepower and mission flexibility. Sensors and weapons create a seamless, layered offensive and defensive capability. The submarine's torpedo room serves multiple roles. It can convert into berthing for special operations teams, with lockout trunks allowing underwater deployment of divers without surfacing. The same tubes facilitate launching small, unmanned underwater vehicles, drones that scout ahead, plant sensors, or undertake risky missions, extending the submarine's reach while keeping it hidden. The push to integrate robotic systems is a clear sign of the future of naval combat. Submarines no longer act alone, but as command hubs, orchestrating a network of manned and unmanned assets. This blend of cutting-edge sonar, adaptable combat systems, and flexible weapons gives the Virginia a formidable edge in clandestine underwater operations. With its power plant humming quietly and sensors tuned to detect the faintest sound, the Virginia-class proves that winning the undersea battle space depends as much on listening and thinking as on diving and fighting. And the moment this silent hunter decides to strike, its next set of tools tells an even more powerful story. modern weaponry, and firepower. The Virginia-class submarine carries an impressive arsenal designed for flexibility and lethal precision. At the core of its offensive power are the Mark 48 Advanced Capability Torpedoes, weapons trusted worldwide for their reliability and adaptability. Over time, these torpedoes have been upgraded with digital sonar systems, allowing them to perform better in shallow waters and outsmart decoys designed to mislead them. Their wire-guided launch system means the submarine's fire control team can guide the torpedo through the critical opening moments of its journey before it autonomously homes in on its target. Initially, Virginia-class boats were equipped with a dozen small vertical launch tubes in the bow, specifically for Tomahawk cruise missiles. These missiles have a range of around 1,000 miles and enable the submarine to strike land targets from offshore positions with high precision. In subsequent production blocks, the Navy replaced these tubes with larger payload tubes, 2 big tubes up front, each holding 6 Tomahawks. This adjustment allowed for bigger and more capable payloads while maintaining stealth and firepower. The most significant leap in strike capacity came with the introduction of the Virginia Payload Module. This involves inserting a mid-body section roughly 84 feet long, fitted with 4 very large launch tubes. Each tube accommodates 7 Tomahawks, bringing the total extra missile capacity to 28 per submarine. This addition increased the overall length of the boat to about 461 feet and pushed submerged displacement to approximately 23 million pounds. This expanded firepower enables a single Virginia to deliver devastating strikes against a range of targets, whether on land, sea, or in contested maritime zones. The capacity to carry and launch dozens of advanced cruise missiles from deep underwater dramatically extends its strategic reach. This makes Virginia not only an undersea hunter, but also a platform for precision strike missions without exposing other assets. Aside from missiles and torpedoes, the torpedo room is extremely multifunctional. It can be changed into a sleeping area for special operations troops, giving a submarine a role as a secret insertion platform. Having a lockout trunk allows the divers to go out and come back in while the ship is under the water. This capability is crucial for reconnaissance, sabotage, or rescue operations in the enemy's territory or sensitive areas. The tubes that are designed for firing torpedoes and missiles are also capable of launching unmanned underwater vehicles or drones as well. These robotic submersibles can do scouting, surveying of dangerous waters, planting of sensors, or coming up as decoys. The Virginia-class can not only increase its operational range, but also take less risk with its crew by the use of drones, which is a combination of traditional weapons and new-age technology. The Navy has vigorously invested in these tube-launched drone systems, using them as part of the drills and tests. The latest trials have already proved that these machines are capable of flying solo for long periods and performing difficult tasks, which has begun to indicate a transition to the use of manned-unmanned submarine fleets integrated together. The mix of firepower and robotics highlights Virginia's involvement as a top-notch warfare platform. Firepower is important, but the manner in which these weapons systems fit into the submarine's stealthy characteristics is the Virginia-class's greatest attribute. The heavy missile payloads, versatile torpedo capabilities, and unmanned vehicle launch and recovery turn this ship into a powerful, flexible, and stealthy one beneath the waves. The ability to deploy special forces and robotic assets marks a new dimension in undersea warfare, blending human skill with machine precision in unprecedented ways. Unmanned systems and special missions. The Virginia-class submarine's design goes well beyond traditional combat roles by incorporating features tailored for special missions and unmanned systems. Its torpedo room can be swiftly transformed into living quarters, for a platoon of special operators, allowing these elite teams to embark on covert underwater missions. This multi-role capability makes the submarine not just a hunter-slayer, but also an intrusion, reconnaissance, and rescue platform capable of operating deep in enemy waters or denied areas. At the heart of this versatility is the lockout trunk, a specialized airlock that allows divers or special forces personnel to exit and return to the submarine while it remains submerged. This stealthy insertion and extraction method ensures minimal risk of detection by enemy forces, preserving the secrecy of sensitive missions. Whether deploying reconnaissance swimmers or underwater demolition teams, the Virginia supports a broad spectrum of naval special operations. The same launch tubes that handle torpedoes and missiles are compatible with unmanned underwater vehicles, often called drones. These underwater robots extend the operational reach of the submarine without putting the crew in harm's way, scouting ahead, mapping the sea floor, or planting sensors in contested zones. They perform high-risk tasks such as mine detection and electronic surveillance, freeing sailors from potentially deadly exposure. Recent tests demonstrate that these tube-launched drones can sustain longer missions and perform increasingly sophisticated functions, including coordinated behaviors and intelligence-gathering operations. The Navy's push toward these technologies signals an understanding that future undersea battles will hinge not only on human crews, but on autonomous systems working seamlessly alongside them. Integrating unmanned vehicles with the submarine's combat system allows for real-time situational awareness and flexible mission execution. Commanders can deploy drones to gather intelligence discreetly or set traps for enemy vessels without surfacing. This networked approach transforms the submarine into a command hub for an underwater fleet, a force multiplier in any conflict. Special forces and drone capabilities represent a strategic leap, providing options beyond firepower alone. They enable the U.S. Navy to project power, gather intelligence, and conduct covert operations with unparalleled discretion. This layered approach to underwater warfare greatly complicates any enemy's ability to counter or predict U.S. submarine actions. Equipped with these capabilities, the Virginia-class bridges the gap between traditional naval combat and modern multi-domain operations. It can engage enemy vessels, launch precise strikes ashore, insert special teams, and manage robotic scouts, all while remaining nearly invisible under the waves. This sophisticated blend of manned and unmanned systems on a silent, fast, and deadly platform underlines why the Virginia-class sets the standard today. Yet the Navy's innovation doesn't stop here. The next generation of submarines aims to push these concepts even further. With that horizon in sight, preparations are already underway for a submarine designed to redefine underwater warfare in the decades to come. The next generation SSNX. The SSNX represents the future of American undersea warfare, a next-generation attack submarine designed to outperform every class before it. Its mission is to combine the speed and firepower of the Seawolf class, the stealth and sensors of the Virginia class, and the endurance of the Columbia ballistic missile submarines. The U.S. Navy aims to create a submarine that can sprint at high speed, deliver overwhelming strikes, operate in near silence, and stay deployed longer than any existing boat. Larger than the Virginia class and potentially bigger than the Seawolf, SSNX is expected to displace around 10,000 tons submerged. This added size allows for more weapons, advanced systems, and expanded mission configurations. It also reflects a shift toward broader roles, including traditional attack missions, command and control functions, and integration with unmanned underwater vehicles. One of the submarine's greatest engineering challenges is balancing high speed with extreme quietness. Faster submarines normally generate more noise, but SSNX is being designed to pursue or evade threats while keeping its acoustic signature hidden within natural ocean noise. This requires major advancements in hull shaping, propulsion, and noise reduction beyond current technologies. Firepower will see a significant upgrade. SSNX will feature enlarged torpedo rooms and additional launch tubes capable of carrying today's weapons and future systems, including potentially hypersonic missiles. Since other U.S. platforms like the Zumwalt-class destroyers and upgraded Virginias are being prepared to fire these advanced munitions, SSNX is being built to integrate them from the start. Autonomy and advanced connectivity are central to its role. SSNX will control unmanned underwater vehicles used for reconnaissance, surveillance, and electronic warfare, giving commanders greater reach while reducing risk. These drones will help map the environment, track threats, and extend situational awareness far beyond the submarine's sensors. The submarine's information systems will be based on the principle of real-time data sharing with all other naval operators, including aircraft, ships, satellites, and drones. The submarine's open architecture software will act as a hard upgraded platform and thus allow rapid improvements without major disruptions, ensuring long-term relevance in a quickly changing digital domain of war. SSN open parenthesis, X close parenthesis will operate a nuclear reactor of very high energy that never needs to be replaced, allowing it to avoid lumbering around with refueling and to support long-term deployments. The use of low-enriched uranium proposals was discontinued because of cost and performance drawbacks. Nevertheless, capability has its costs. Each SSNX is expected to cost between $7 and $9 billion, thus necessitating the company to underwrite innovation with budget constraints. To avoid reincarnating the past program's missteps, the Navy is going to give priority to scalable and achievable innovations. The underwater war is becoming the Navy planned to use SSNX as the main weapon for mid-21st century superiority. Faster, quieter, and more lethal than the fleet of submarines today, thus not only maintaining, but also reinforcing. America's newest underwater weapon marks a breakthrough born from decades of relentless innovation, blending near-invisible stealth, formidable strike capability, and next-generation intelligence systems. As silent predators patrol the ocean's depths, and future submarines evolve to outthink and outmaneuver any rival, a new chapter in undersea warfare is unfolding. If this exploration of naval stealth captured your curiosity, be sure to like, subscribe, and watch the next video shown on the screen as we continue uncovering the technologies shaping the battlefield of tomorrow.